Hello and welcome to the data warehouse tutorial. In this video, we'll talk about what a data warehouse is, why it's important, and how it can benefit companies. We'll also look at the main components and the architecture of a data warehouse. This is the first video in a series of training videos. In future videos, we'll cover more advanced topics. On this channel, you will find other videos on data analysis, data engineering, data science, and AI. If these topics interest you, consider subscribing so you can stay updated on new videos. Now let's get into today's topic. Let's start with the basic question. What is a data warehouse? A data warehouse is a central place or a database where data from different sources is collected, organized, and prepared for analysis. For example, let's say we have a company that use systems like ERP, CRM, and HRM to manage many operational processes like production, customer management, finance, and HR. Databases that process and store the data behind these systems are known as operational or OLTP systems or databases. These systems are designed to handle large volumes of transactions, perform real-time data entry and retrieval quickly, run short and simple queries like adding, updating, or deleting records, have a normalized data structure, and are expected to be always available. These features ensure that companies' operational processes run smoothly and efficiently. On the other hand, there are analytical databases, often called OLAP, online analytical processing systems. These systems are used for data analysis. The structure of OLAP systems makes it easier and faster to run complex queries on large datasets. Data warehouses are a type of OLAP system as well. OLAP systems can handle large amounts of data, which are usually updated regularly, like daily, hourly, weekly, usually not real-time. Run complex queries and aggregations, have a partially denormalized data structure, and typically store long-term historical data. We have mentioned some important concepts here, like normalization and denormalization. Let's take a closer look at them. Normalized data format is all about organizing database tables to minimize the data repetition and maintain data accuracy. But what does that mean? Let's break it down with an example. Imagine a table where sales data is stored in a completely unorganized way. While this structure isn't commonly used in databases, it's a useful example to understand these concepts, where sales data, product information, and product categories are all in the same table. This setup causes data to be repeated, making database management more difficult. Product names, category names, and other product details get repeated as many times as there are transactions for that product, potentially leading to hundreds or even thousands of duplicate entries, which bloats the data size. What's data accuracy, data integrity? Integrity refers to correctness and consistency of data. For example, if you need to change the name of a product, you'd have to find and update every row in the table where that product is mentioned, which could mean hundreds or thousands of updates. This makes data management difficult, and if the process isn't done correctly, you could end up with inconsistencies like having different product names under same product code. This is what we mean by data integrity. So how do we fix this? We normalize the table by separating product information into a different table and giving each product a unique ID. This ID is a primary key, meaning it shouldn't change under any circumstances. In the sales table, instead of repeating product information, we reference the product ID. In this table, this ID is known as foreign key. By doing this, we avoid repeating product names, categories, and other product details. But what if we need a denormalized structure like the original table for analysis? In that case, we can join the two tables using the primary and foreign keys to bring the necessary product information. And in this structure, we partially denormalized or partially normalized our data structure. It's making it easier to perform certain types of analysis while still keeping data organized and efficient. In this example, the sales table is called a fact table. Fact tables store measurable and numerical data like sales quantities, sales amounts, costs, and other performance metrics. But the product table is known as dimension table. Dimension tables contain descriptive information that gives context and meaning to the numbers in the fact table. In this case, the product names, categories, prices, and other attributes in the product table provide context and meaning to the sales quantities, sales amount, etc. in our fact table and help us to categorize these metrics. For example, we could see how much we sold of a particular product or category. Usually, a fact table is linked to several dimensional tables. In a real scenario, the sales fact table might be linked to product, customer, salesperson, and even date dimension tables. This creates a schema with a central fact table surrounding by several dimension tables, which is called a star schema because it looks like a star. Let's get rid of additional tables and return to our main example. Another point worth noting is that the product table can be further normalized. For instance, we might see that the category data in the product table is repeated as well. In this case, we could move the category information to a separate table and create a primary key and foreign key like we did in the product table, and this results more organized schema known as Snowflake schema. This structure further reduces data repetition and increases data accuracy, but it requires more joins to combine the data in these tables for analysis, which can slow down queries. For this reason, star schema are generally preferred over Snowflake schemas in data warehouses. Whether you create a star schema or Snowflake schema, this type of data modeling process is called dimensional modeling. Dimensional modeling is a method of organizing database tables around fact and dimension tables. Okay, let's look at key components of data warehouses. A data warehouse has several key components. First, data sources. These are systems where data is first collected. They can include OLTP systems like ERP, CRM, HRM, we talked about earlier, float files such as Excel, CSV, JSON, XML, or other various sources. Then we have ETL processes. This is one of the most important components of a data warehouse. ETL stands for extract, transform, and load. Extract means pulling data from source systems. Transform means cleaning and transforming this data. Load refers to loading the transformed data into the next level. Various software can be used to manage ETL processes such as SSIS, ODI, Apache NiFi, Talent, Informatica, and etc. And we'll cover some of these technologies more extensively in future videos. The next layer is data warehouse, also called data storage. This is the central part of the data warehouse where data is stored long-term. This storage is designed to securely and efficiently store large amounts of structured data. The data is stored here in a way that is optimized for analyzing and reporting. Everything we talked about data warehouses earlier also applies here. And next layer is presentation layer. In this layer, we use tools to analyze and generate reports. This layer, we can use various technologies such as business intelligence platforms. Examples include Power BI, Tableau, Click, and etc. These four main parts form the building blocks of data warehouse system. It has its own subparts and processes, but understanding these high-level groups help to grasp the overall functioning of data warehouse. Now let's take a deeper look at the architecture of the data warehouse or the data storage layer. A data warehouse usually has three main layers: the staging layer, the core layer, and the data mart. People usually mean core layer when they talk about data warehouse. although the term data warehouse actually includes all these layers. First, let's take a look at the staging layer. Why do we need the staging layer and how does it work? As we mentioned earlier, data comes from source systems. These systems are usually operational systems that run all the time within the company. When creating a data warehouse, we don't want to spend too much time or put too much load on these systems with data extraction or transformation processes. Doing so could negatively affect their performance. In simpler terms, we want to avoid running complex queries with joins, aggregations, and functions directly on these source systems. Instead, we aim to quickly extract the data with minimal transformation and load it into the staging area. The staging layer also plays a key role in organizing data from various sources like Excel, CSV, JSON, XML files, which might come in different formats and unstructured. In this layer, the data is stored in the relational database tables, create a consistent format that's easier to work with. Once the data is structured in the staging area, we can move on to cleaning and transforming it with our ETL tools. Now that we've cleaned and transformed the data in the staging layer, and the next step is to move it to the core layer. The core layer is the heart of the data warehouse. It's where all the data is centrally stored and organized. This layer is designed to store data that has been optimized for analysis and reporting over the long term. As discussed in the dimensional modeling section, the data here is usually stored in partially denormalized form to improve query performance. Everything we have discussed so far about the Dataverse, whether it's data consolidation, historical analysis, or performance improvements, primarily concerns this core layer. Lastly, let's explore the concept of data mart, which is considered the final layer in the data warehouse structure. A data mart is a smaller, more focused version of a data warehouse. This layer is designed to meet the specific needs of particular business units, departments, or use cases. Types of data mart. First, department-based. For example, departments like sales, marketing, or human resources might have their own dedicated data marts. Data marts can be customized for different geographical regions. Data marts can also be created to serve different use cases, such as data visualization, predictive analytics, or machine learning purposes. Now let's look at features of data marts. First, focused. A data mart is tailored to serve a specific business area or department. It has smaller size. Data marts typically contain less data than a full data warehouse. Faster queries. Because they manage smaller amounts of data, queries in a data mart tend to be quicker. And ease of use. Data marts are generally easier for end user to understand and manage because there is only the information that this unit concerned about. In short, a data warehouse takes raw data, cleans and transforms it, and then organizes it to meet specific business needs. To finish, let's look at key benefits that data warehouses offer to businesses. As we have discussed, data warehouses bring many advantages. These benefits include, first, data consolidation, bringing together data from various sources and providing users with a single point of access to this data. Historical analysis, allowing businesses to analyze past data and evaluate long-term performance. And performance boost, performing analytical queries in a data warehouse reduces the burden on operational systems, improving the overall performance of OLTP systems. Since operational databases are optimized to handling daily transactions, running heavy analytical queries on them can negatively affect their performance and can cause issues on business operations. However, then these analyses are offloaded to the data warehouse, the operational systems can focus solely on managing daily transactions. Reliability. Data warehouses ensure data accuracy and consistency, which enhance reliability of analysis. For instance, different departments within a company might have their own systems and reports, leading to inconsistencies in metrics. A data warehouse consolidates all data from all these sources, standardizing it to ensure consistency and accuracy. And this allows all departments to work with the same reliable data source. For all of these reasons, we call data warehouse as single source of truth. There are actually more benefits we could discuss, but I think this gives you a clear understanding of main advantages of having a data warehouse in your company.